Okay, so picking up where we left off, let's have a look at another example where we need to restrict the range in order for the composite function to exist. So we've got f of x is 3 minus x, but we need to pay attention to this. Okay, we've been given a domain here that x is less than or equal to 3. And then over here we've got g of x is x squared minus 1 for all the real numbers. So show that f of g is not defined. So what we want to see is that the range of g will not fit into domain of f. Okay, so remember we're doing g first. Okay, so let's have a look at the range of g is y is greater than or equal to -1, but the domain of f is that x is less than or equal to 3. Okay, so at this point this is fine up until 3, but then it's going on to infinity, so any numbers that are greater than 3 are going to be a problem there. Okay, so we've shown that range of g, which was y is greater than or equal to 1, -1, is not a subset of domain. Oops, not that way. That way. So y is greater than or equal to -1 is not a subset of range being less than or equal to 3, which is, sorry, range of the domain of f. Okay, so range of g is not a subset of the domain of f. So that proves that f of g is not defined. So then the question B says find a restriction. So basically come up with another function g star such that f of g star is defined and find what that is. So it's just like we were doing in the previous example, we need to work out how we're going to restrict that first function g such that it only spits out values that will go into f, okay, for this. So if we know that the domain of f is less than or equal to 3, we need to make sure that the values that come out of here, so these values of g of x, must fit with that. Okay, so what we can say is we know that g of x must be less than or equal to 3. Okay, so that's in order to fit in with this domain. Now we've got x squared minus 1 is g of x, that's going to be less than or equal to 3. X squared is going to be less than or equal to 4. And again, using our little diagram, okay, we've got x squared, we've got 4 up here. Okay, we know that's going to be minus 2, that's going to be plus 2. But this time we're actually looking for this bit in here. Okay, because we want the value such that x squared is less than 4, less than or equal to 4, so in there. So in this case, the values for x that we're looking at are actually between -2 and 2. Okay, so then we can define g star. G star is going to be x squared minus 1, so it's the same function, but given that x is between -2 and 2. Okay, and if we apply that restriction, then that will mean that any values that come out of here will then be able to go into f of x. Okay, now the last thing it said was find f of g star, and then this is pretty straightforward, so this is just where we do our usual 3 minus, and so we're doing f of g. Okay, so f of 3 minus x squared minus 1, and when you expand that out, you get 4 minus x squared, such that x is restricted, like so. So in summary, we use the machine analogy to remember the order of domain and range for each function. So if you ever get stuck, just remember that if you're doing it like this is first, and this is second, so it's backwards, or if you're remembering the in terms of brackets, f of g of x, do the internal brackets first, and then just draw a little picture either on, in your head or on the page, which just says g goes into f. Now you know that the numbers coming out of here must be going into there, so it's range of g must go into domain of f. So that's for a composite function to exist, the range of the first function, g, must fit into the domain of the second function, f in this case, or in reverse if you're doing cof. If it doesn't exist, then you can restrict the domain of the first function over here and make sure that you only get out values that will go into there. Okay, so you kind of have to work it backwards. You need to look at what values go into here. Okay, this becomes my range, and then how do I have to change the domain of this to make sure that I only get those values out. And just a note that I haven't sort of really gone into yet, but is fairly common sense, is that the domain of any composition will be the domain of the first function. Okay, so obviously any numbers that you're putting into your fog function, okay, must be able to go through G. So if they can't go through G, then they obviously can't go through f of G. So it's easy to determine the domain of your composition because it's just the domain of your first function.